Hi, welcome to your lesson on adding and subtracting radical expressions. It is time for radicals, and this lesson is putting together all your skills so far. Maybe gets a little bit tougher than we've seen so far. In the first part of this video, just listen and see what's happening. You won't begin taking notes on the notes page provided to you until a little bit later. Let's do a recap. Here's some rules we know about surds or radicals. When you multiply two radicals like this, you can combine them into one radical with the multiplication underneath there. Here's an example of that. We have two radicals. We can combine those into one. It combines into one by going under one radical like that. So we have root of 100, 5 times 20, and the root of 100 is 10. Let's look at root of 75. That one we can work backwards. As we know, root of 75 is 25 times 3. We can break that into those two radicals. All right, we've been using this idea for a while, but we usually don't write it as two separate ones, but you can do that, and then we get 5 root 3. All right, the rule for dividing surds is if you have a fraction under one radical, or one surd, you can break it up into two separate radicals with that fraction. So an example of that is this. Here we can combine those into one. Root of 80 over root of 20 can combine into one root of 80 over 20. 80 by 20 is 4, and the root of 4 is 2. Another example of that, here we have 15 divided by 4. That can break into two separate radicals, and the bottom one we can take a square root of. Square root of 4 is 2, so we can leave it like this. Here's another example. We have two separate radicals. Can you combine and simplify that? Definitely. We can combine it into one like this. One radical, 125 divided by 5, which is 25, and the square root of 25, as we know, is 5. All right, what happens when there's a number outside the surd or outside the radical? And multiplying here, you just multiply the number on the outside and you multiply the two roots. So 3 times 2 on the outside, 6 times 24 on the inside. So we have 6 on the outside, 6 times 24 is 144, and the square root of 144 is 12. So this turned into a 12, and we have 6 times 12, which is 72. All right, now let's look at adding and subtracting surds. That's the topic of this video. Let's say you had root of 9 plus root of 4. Well, the root of 9 is 3, the root of 4 is 2, and 3 plus 2 is 5. So we know the result of this is 5. You may be tempted, looking at the rules we've done already, to think that this is the same as this. Just taking those and combining them like that. We did that for multiplying. If this was multiplying, we would just combine those into one. But this is addition. Let's see what happens. Combine it under one root sign. 9 plus 4 is 13. And the root of 13 is actually 3.6055. It's some irrational number. So clearly, the result of this is not the same as the result of this. So what that tells us that this cannot be combined like this. So be careful when adding and subtracting surds. You cannot just take 2 and make it into 1 like that. That only works for multiplying and dividing. All right, so with that in mind, just remember, this is not a true statement. Cannot combine those, so no, let's just emphasize that idea so that you don't make that mistake in the future. Let's look at two examples now of how do we deal with combining surds or radicals. Well, let's look at this. In algebra, you know, those are called like terms. You have some number of x's plus some other number of x's. Here we don't see a number, but it's 1x. So we have 1x plus 2x. And then you can combine those like terms and get 3x. Altogether, there are 3 x's here. Let's look at radicals the same way. Here we have a square root of 3 plus 2 square root of 3. I want you to notice that this is just like this. We have 1 of something here plus 2 of that same thing. Here we have 1 root 3 plus 2 root 3. So altogether, how many root 3's do we have? Well, those are also like terms. So we just combine the number in front and we have 3 root 3's. We have 1 of them here, 2 of them here, combine that, 3 root 3's altogether. It works just like this. All right, so let's take some notes now. You're going to use the page that was given to you. On that page, on top, it says a note. Surds can only be added or subtracted if they are like terms. So here's an example of something that's done correctly. Here we have two surds. This is a like term, root 2 and root 2. So you can just combine those. We have 5 of them here, 3 of them here. That means in total we have 8 of those. We have 8 root 2. Here's another example that's correct. We have 7 root 5s minus 4 root 5s. So 7 of these minus 4 of these. That means altogether we have 3 of those, 3 root 5. Here's some incorrect examples. Write them on the incorrect side. Root 2 plus root 3. Well, those are not like terms. So you may be tempted to combine them like this, but that does not work. That's the point we've been trying to really highlight here so far. So that's not right. Also, another incorrect example is this. We have 2 of those minus 3 of these. You may think, well, 2 minus 3 is negative 1, and then combine those on the inside to make 13. No good. So again, these are incorrect. Let's make sure we only combine like terms when we combine radicals. So let's look at some examples. Here's an example with 3 terms. So far, these are not like terms, so you can't combine them as they are. But you've learned how to simplify radicals, so you know how to simplify all these. If you simplify them, you might end up with some like terms. So try to simplify this and see what you get. Well, first, hopefully you noticed that this is 9 times 7, and this last one is 4 times 7. So here we can take the square root of 9, and a 3 comes out. Here we can take a square root of 4, and a 2 comes out. Now we actually have all the same radicals, radical or root 7, root 7, root 7. So you can combine all those terms, 3 of them minus 1 of them plus 2 of them. That result is 4 root 7. Another example, now we have 4 terms. Let's see if we can make some like terms there. Maybe some of them will be like terms, maybe all of them. So try to reduce all these or simplify them. Let's see what we get. All right, hopefully you noticed here, 72 is 36 times 2, 27 is 9 times 3, 75 is 25 times 3, and 8 is 4 times 2. So here we can take a square root of 36, here a square root of 9, here a square root of 25, and here a square root of 4. Square root of 36 is 6, that one, square root of 9 is 3, square root of 25 is 5, and square root of 4 is 2. So now you have this written out in simplified form. See if there's any like terms. Well, I see a root 2 here and a root 2. Those can be combined. And here we have a root 3 and a root 3. Those can be combined. So what's the final answer? 8 root 2, because 6 root 2's plus 2 more root 2's is 8 root 2. 3 root 3 minus 5 of those is negative 2 root 3. All right, let's try another one, see if you can simplify these two. In the first one, notice we already have a common like terms there, so we just combine the first two numbers, 6 root 6. Second one, they're not like terms, so you might have to simplify. All right, that one turns into this, 2 comes out, now we have like terms, we have 2 plus 1 of these, so 3 root 2. Couple more. Hopefully with that first one you noticed everything's been reduced, it can't be reduced anymore, they're not like terms, so you leave it as is. You cannot do anything else with that. Second one, give it a try. All right, in this one, 48 becomes 16 times 3, 32 becomes 16 times 2. Remove a 4 from each of those. 4 comes out, and we end up with 4 of these, 2 of those, and again, these are not like terms, so you stop there. You cannot combine those at all. All right, some more on the back, lots more. Let's keep going, you can do it. These are just easy ones here, because there's a lot of like terms that you can see. First one, 2 root 3. Just subtract the like terms. Next one. Negative root 5. Because you have all like terms, 2 plus 4 minus 7. So that's 6 minus 7. Negative 1 root 5. Next one. Please ignore this little comma there. That's not supposed to be there. All right, that one you have 2 root 2 minus 2 root 3. All right. 6 root 2 minus that is 2 root 2, and this one combine to make this. Last one. In this one we have 3 root 5 minus 2 root 5 plus 4 root 5. Those three can be combined into this 5 root 5, and then you're left with this 5 root 3 here. a separate piece. All right, last bunch here, and these ones will be the toughest ones. Let's see if you've worked all your way up to these problems here. Simplify and then combine if it can be. Okay, in the first one, we can take that step. Pull out a 3 here, pull out a 5 there. We have all like terms. They combine into 7 root 2. Next one. That 108 is 36 times 3. This 75 is 25 times 3. And this 48 is 16 times 3. Pull out a 6 here because the root of 36 is 6. Pull out a 5 here. Pull out a 4 here. All like terms combine to make this. Next one. In this one, this is 16 times 7. Then we have this negative root 6 minus root 7. And 150 is 25 times 6. 4 comes out here. These remain the same. 5 comes out here. Look for common terms, like terms, and combine them. That's what you get. And the last one. All right, 40 is 4 times 10. 1000 is 100 times 10. 20 is 4 times 5. And that one remains the same. Here you can take out a 2. Here you can take out a 10. Here you can take out a 2. So that's what you get. Combine like terms, and you get this final answer. All right, good job. Hope you had some success with those. Please come prepared to try lots more problems like that to build up your skills. We'll see you soon.